Okay, YouTube, in this video we're going to confront how we long divide polynomial functions. Given two polynomial functions, how we can divide one by the other one. So let's go ahead and start by considering this division problem up here. But we have, you notice your division box here. On the outside, x plus 3, and on the inside, x squared plus 10x plus 21. So really what I want to start with here is just kind of pointing a few things out. Starting with this right here. This is what we're going to refer to as the thing we're dividing, is the thing we refer to as our dividend. So we have a dividend, and what I want you to notice is that it's a polynomial. As a matter of fact, that polynomial, usually the thing that we're dividing is just some function f of x. But that's our dividend, and we say that this thing that we're dividing by, this thing on the outside here, that's actually our divisor. And I want you to notice also that it is a polynomial on its own. It's a first degree polynomial, so we're going to refer to this as d of x, some polynomial function d of x, but we use d just to represent the divisor. Okay. So we're starting with our divisor dividing the dividend here, and the thing that's being divided goes on the inside of this box. So now you notice that both of these are written in standard form. We have x squared plus 10x plus 21, and on the outside x plus 3. So setting this up, essentially what we're going to do is we're going to use the same division algorithm that likely you learned when you did this with numbers. So for instance, if I had 123 divided by 2, then I could really use what we call the division algorithm here. We say DMSCB. And what this stands for is divide, multiply, subtract, carry down, so carry down, and begin again. Okay, and loosely, this is the order of that we'll go through things here when we divide. So starting with this, we'd say 2. How many times does 2 go into 1? And actually, 2 doesn't go into 1 any times, but we say how many times then would 2 go into 12? That's 6. Now here's the thing. When we put that up here, we did our division part of this. Now we're going to do the multiply part, which says we'll take this up here times the divisor out in front. We get 12 in this case. So where the subtract comes in is where we're going to subtract off this right here, all of this, and we get nothing left behind. And so the carry down part now becomes this, let's bring down the 3, and then we begin again, except for this time we're saying how many times does 2 go into 3 evenly? And the answer to that, of course, is 1. So we'll multiply again here. We get 2, subtract 1, and there's nothing to carry down. So this is pretty important here, but we're going to label this. This is our remainder. Okay, so what we get up top here is our quotient, and that's the answer to our division problem. So we got 2 to go into 123, not evenly because we did get a remainder, but we have our quotient here as well as our remainder. So we're going to use the same method here when it comes to dividing polynomial functions. So I'm going to start by rewriting this. And you should have some room, I would hope, here on your paper. But what we're going to do is we're going to start with these terms in front. These terms in front. Just like I started with the 2 here and the 1 here, I need to start with my x here and my x squared here. And what we're going to ask is, how many times does x go into x squared? Now, to answer this question, x squared, how many times does x go into it? It's a division problem here. We could say that it goes in some unknown number of times. But if I wanted to answer this question, well, another thing we could do is we could multiply both sides of this equation by x. This is not something you're going to have to do, but I want you to notice that when we ask this question, what could I, excuse me, how many times does x go into x squared? Really what we're asking is, what else could I take times x to get x squared? So because I can take x times another x to give me x squared, I'm going to put that x up top here. And notice that I put this x to the first over this x to the first term. So what I just put up here was our division part of this, the divide part of our DMSCB. And by the way, I remember this, somebody told me once, does McDonald's sell cheeseburgers? That question, if you can remember that question, then you can remember these here. But we're going to take this now, we're going to do our multiply part. We're going to take this x times all of what's out in front of our divisor. So x times x, we get x squared, and x times 3, we're going to get 3x, and I'm going to write that underneath my 10x here. So I'm going to put parentheses around this, and that's really important because what we're going to do is we're going to subtract all of this. If you don't put parentheses around this, the number one mistake is that the negative that people put there, they only apply it to the x squared, say in this case. So we're going to rewrite this as addition, adding the opposite. So this will become negative, and this will become negative. And what happens is when we add these together now, those cancel out, and we get left with positive 7x's, plus now we're going to carry down that 21 and begin again. So we say, now how many times does x go into 7x? And what could I take times x to get 7x? I could take it times 7. So I'm going to put that positive 7 up on top of my constants here. And now we're going to take that 7 times everything over here. So I get 7 times x is 7x. 7 times 3 is 21. And we're going to subtract all of this off right here. So adding the opposite. Something really neat happens here, actually. We get 0 for a remainder. So our remainder, we're going to make sure we label that right there. But what we get is this. And it says we're taking notes here. We're going to say that this is our quotient. Okay. This is our divisor. And this is our original function, our dividend. okay, dividend. So one thing I want to point out here is this original function f of x that's inside of here. If we were to take the divisor times the quotient again, we should get back what we started with. And so one thing is for sure, we could use this division as a good tool to say that, look, if I know one factor, I can divide it out, and what's going to happen is it's going to leave behind this other factor. So here's our divisor times our quotient to give us back the original product. So this, just basically this method we run through is going to work for any long division. So let's take a look at this next example before we finish this video. We say our dividend is this value in here. We say x squared plus 14x plus 45. And then on the outside, our divisor is x plus 9. So let's go ahead and get this started. We'll start with our divide. How many times x goes into x squared? Or what we could take times x to get x squared. So x is what we could take times x to get x squared. X times x is, of course, x squared, and x times 9 is 9x's. So we're going to put parentheses around this and subtract all of it. So now adding the opposite, we get these to cancel, and 14 minus 9 here, that's going to give us a positive 5x. So we'll carry down our 45 and start up again. Again, we say, what could I take times x to get 5x in this case? We say, well, then 5 would be it. So 5 times x is 5x. 5 times 9 is 45. So we get subtracting all of this. Again, we get adding the opposite, no remainder, which is pretty cool. So we could say that this is our quotient right here. Okay. So as we go forward, we're going to put this to use, but this table essentially lays out this long division process here. So we're going to arrange the terms of both the dividend and divisor in descending powers by variable. We're going to make sure that they're written in standard forms. Standard form. Number 2 says divide the first term of the dividend by the first term of the divisor, which is what we did, but it says the result is the first term of the quotient. And then we're going to multiply everything in our divisor here by what we put up top. So whatever we put up top, we're going to multiply the divisor by this and take what we get there, and we're going to subtract that off is what this says. So subtract that product from the dividend. Then bring down the next term of the original dividend and write it next to the remainder to form a new dividend. So essentially, we're just going to keep doing this. It says use this new expression as the dividend, and then repeat this process until the remainder can no longer be divided. So we're just going to keep going and going until we get a remainder that can't be divided by the divisor. And that's what we'll call our quotient. Cheers.